Let's consider this question again. Flight times from LAX to New York are normally distributed. So we have that same question. Flight times, a random variable, the flight time, we can change, is normally distributed. And we're also told that the average flight time is 320 minutes and the standard deviation is 20 minutes. And we're asked to find the probability that the flight times are less than 300 minutes. So we can actually solve this. We've done this before, but let's just do it again. So that's just going to be, we can just do it from up here. We can just use norm.dist and we're going to put in our 300 and then we're going to put our 320 in and then we're going to put in our mean, which is 20, and our standard deviation, which is 1. So let's quickly go over to Excel and do that. So it's going to be equal to norm.dist and 300, 320, 20, and 1. And we're going to get an answer of 15.87%. We can make that a little bit more accurate. If we want to change the decimal places, we can add more, we can take some away. But it's 15.87%, so let's just go here. So the answer here is going to be 15.87. And it was easy to do because we didn't have to make any adjustments. Excel works out the area to the left, and we did indeed want the area to the left of that point. So now let me ask you this. If I tell you there is a time such that, and I'll draw it out for you as well, let's do it here. There's a time for this question as well. So normal distribution. The mean is 320 and the standard deviation is 20. I would tell you there's a time such that, right here, don't know what that time is, but the time such that 15.87% of flights 15.87% of flights take less than that amount of time. So the quickest 15.87% of flights, they're the quickest because time increases as you move this way down this axis. So what is that time? That's what I'd like to find out. Now there's a quick way to do it, which I recommend you do it. But this occasion I will show you first of all the slow way and then the quick way. So what I'd like to work out here is the probability, the shaded area I've done is the probability that the time it takes is less than, well, I don't know, but I do know what the answer is. The probability that it takes less than question mark is going to be equal to 0.1587 or 15.87%. What is that time? I'd like to find that time out. So what I'm going to do now is standardize. Now standardization process is always the same. You write out your equation, there's some spacing in there, and then I'm going to subtract the mean from both sides. Here I'm going to use letters, and here I'm going to use numbers. So the mean is 320, and then I'm going to divide out by the standard deviation. I divide out by the standard deviation, which is 20, and that equals 0.1587. Now I know that x minus mu over sigma is z, and z means standard normal, so we just standardize this. Still don't know what this question mark is though. Minus 320 over 20 equals 0.1587. So we can do a graphic of that as well. Let's do a graphic of that. So graphically what I've done is I've transformed this question above to, there's a question above, right there. Okay, I've transformed that question at the top of the screen to this one here. I've gone from x to z, standard normal, it's normal distribution, but standard normal, which means the mean is 0, and the standard deviation is 1. And this point here is now going to be not just question mark, but it's going to be question mark minus the mean over the standard deviation, and the actual answer to that is going to be 0.1587 or 15.87%. How do I solve that? By the way, the transformation process from here to here is the same one, is x minus the mean over the standard deviation, and this value in here was before, it was a question mark, it was a question mark up here, and when I subtract the mean of 320 and divide by the standard deviation of 20, I actually get this value in here. So we've just transformed the problem. Now, XOR does have a function available to us, fortunately, that can help me out. It says, well, I have a standard normal distribution, so Z. We have actual tables that Gauss came up with, but also XOR has functionality in there. And it says if the area to the left of any point is p%, then we can work out the value of that point. So we're doing it in reverse. We've got the percentage up here, and we're going to find this value here. And in this case, XOR says that the function that's going to work out this question mark here is going to be norm dot s. It's going to be dot s because I'm dealing with the standard normal. Dot inverse. So inverse means I'm going to do the question in reverse now. I'm not trying to find the probability. I've got the probability. I'm trying to work backwards. I put the probability in here, and that's it. In our particular case, our probability is going to be 0.1587. So I can actually do a norm dot s dot inverse of 0.1587. Norm dot s dot inverse. Let's pop over to Excel and do that. So let's do it here. So I can do equals norm dot s dot inverse of 0.1587. What does that give me? So what does that give me? That gives me minus 0.9998151. 9998151. Let's go over here. So this equals, in fact, did you notice that that value was negative? So it's going to be negative 0.9998151. So these are basically identical. So here, when the area up here is 0.1587, I have this value. But I've worked out now that when the area up here, when p equals 0.1587, this value, this question mark here, is going to be 0.9998151. So that means this in here, this question mark, which is not the same as the one over here, minus 320 over 20 is equal to negative 0.9998151. And I can rearrange this formula into question mark is equal to 320 minus 0.9998151 times 20. So we can pop over to Excel and do that. We already got this value in there, so I'm going to multiply that value by 20 and add 320 to it. So I can take this value that I have above, I can multiply it by 20 and add in 320 to it. And what's that going to give me? 300. To 2 decimal places, it's just 300. Let's go back over here. So question mark is equal to 300, approximately 300. There was a couple of decimal places off. So that was a long haul, wasn't it? So we managed to find out that this value in here is about 300. In fact, what I just did, I asked you the same question I asked you initially in reverse. Initially, I said to you, what's the probability that it takes a flight less than 300 minutes to go from LA to New York? And the answer was 15.87. This was actually 0.1587 or 15.87%. That was the answer. But this time, the second question I asked you just below, I said, if this is 15.87, then what is this flight time in here? And it's got to be 300. It's got to be this. I asked you the same question in reverse or in inverse. So it was a lot of work to actually calculate it the long way. But Excel, again, as you probably guessed, has a nice function. I'll write the function up here for you. It says if you have a standard normal distribution and you know the mean and the standard deviation, and this area in here is p%. Excel can work backwards and work out this value in here for you, which is exactly what we want to do for this question. We've got a percentage of 15.87. We want to work this value out in here. So Excel says to work this out, you're just going to use a function which is norm.inverse. There's no s in it because now we're dealing with any normal distribution. Here it's not the special case of the standard normal. And then we're just going to tell it what the percentage is. We're going to tell it what the mean is. And we're going to tell it what the standard deviation is. And it will go straight to an answer. So that is all you need to do to get to the answer. You do not need to go through all of this I've done here below. So for this particular question, how would we do it? To find this value in here, we can just use norm.inverse of 0.1587. But the mean is 320 and the standard deviation is 20. And let's see what that gives us. So we can use norm.inverse 0.1587. Let's go over here. Let's do equals norm.inverse 0.1587. If you forget what Excel needs, it tells you there. Now it wants the mean, which is 320, comma, then it wants the standard deviation, which is 20. And hopefully that's going to come to, there you go, 300. It's not exactly 300, but it's approximately 300. The reason it's not exactly 300, when I was working backwards, I told you the proportion to use is 15.87%. The real value we should have used was this value in here to more decimal places, but I rounded it, so that slightly changes the answer. So there you can actually work out an inverse problem very, very easily, just remembering to do this. But this only works if the proportion or the area, the percentage, is to the left of the point. If the area to the left of this point is 0.1587, which is what Excel wants, the area to the left, I could have equally asked this question and said that there's a point such that 84.13% of flight times are greater than that time. It's the same time. So 84.13% of flights take longer and 15.87 take less than that particular time.